Okay, this is the India's joint entrance examination. It's not the full exam, but I'm just going to give you a partial idea of what's going on here. It's an entrance exam, and the entrance exam is to get you into a good college in India. I think the best college in India is ITT. All right. So I want to point out that the exams are they really lend themselves to what I call memorization. Like you'd have to know a lot of different things and be able to do them quickly. That of course sets up institutes where people are being coached to do well in the exams. Not unlike the United States with the SAT or GRE or or LSATs or MCATs. But it really depends a large part of memorization. All right, so I want to point out that the memorization really can allow you to do problems incredibly quickly. By the way, so for example, this problem over here, and they're given 1.5 minutes to do the problem, right? And then the thing about this, they want you to evaluate the integral. It's not an easy integral. Like looking at it, I think if you were like a creative individual, not memorizing, trying to do different things, you'd have a tough time. You wouldn't get it in 1.5 minutes, by the way. But I want to claim to you that they give you three integrals, and the integrals look remarkably similar, by the way. All right, remarkably similar. So what I want to do is just go through what some students in India would memorize. All right, and what they would memorize. Let me go over here. They would memorize this fact over here, which would allow them to integrate this problem in a matter of seconds. What I'm going to go through is how did they get this formula over here? Like, where did this come from? And this is not something we would give a student in the United States. They will memorize that, and then we'll give you problems related to that. All right? So I want to go through it, and by going through it, I want to just put down that, I'm writing down that this looks sort of like this one here, sort of like this over here. All right? So what I would do is do u substitution. I'm just generalizing it. And, du would be minus dx. Then I make my substitution. All right? So, let me just write this down. U is equal to a plus b minus x. Certainly du is minus dx. It's pretty simple. And then I would write down x equals a plus b minus x. Then I make the substitution. For example, the upper limit is b corresponds to the x. I plug it in. What would you get? You would just get a. The lower limit's a. If I plugged it in, again, I'm plugging in over here, you just get b. All right? What's x? It's a plus b minus u. A plus b minus x is u. And again, x is a plus b minus u. Du is minus, I'm sorry, dx is minus du. Then I noticed about this, the opposite of that integral. I just change the, reverse the limits of integration, and I get this over here. All right? So then the thing becomes is you're looking at this and saying, well, it didn't really lead anywhere. It did. And I'll tell you what it's leading to. It's leading to the fact that, let me write this one down for you, that, I'll write this, let's write this down. So let's write down A, B, F of U. I'm just copying this thing again, by the way. I'm making different letters in it. And it's going to be F of A plus B minus U plus F of U du. That's equal to x, right? That's a big X, by the way. Plus, let's write this one down. It's also equal to x. So I'll write this over here. And what do you get there? A to B, F of A plus B minus U over F of U plus F of A plus B minus U du. You add those two together, and that's all I'm doing over here is adding them together. And what do you get? You would get, it's highlighted for you, you certainly get 2x when you add them together. And when you add these two integrals together over here, you actually just get this over here, which, again, it looks worse, but the bottom line is what you're noticing over there, it's just 1. All right? And that's provided these things are well behaved. We're assuming that with the problem given us. And then I can integrate that, and it's going to be u, evaluated from a to b, so just b minus a equals 2x, and I can solve this. So this is the important result over here, right over here. And, certainly I took, more than 1.5 minutes to figure that out. Certainly it took time to think about that. I would have failed the exam already. I wouldn't be able to even get to the second question. All right, but the bottom line is, if you knew this, you could directly apply it to this thing over here. Directly. What do I notice about this thing over here? Well, looking at it, 4 plus 2 is 6. It's in the proper form. It's exactly like it. So what I'm going to do, just take the limits of integration, 4 minus 2, divide by 2. Well, 4 minus 2 is 2, and 2 divided by 2 is 1. So if you knew this, you could write this down in less than, I'm going to say 3 seconds, if you knew that. If you didn't know that, you're not going to get that in even like 2 minutes, 3 minutes, 4 minutes. Take time, all right? So memorization plays a factor, all right? Let's look at the next one. And the next one is sort of like this one over here, but it's different. So what I'm going to do is I'm looking at this one over here, and it's more difficult, by the way. This is a more difficult question. But I do notice it's of the same form. But the problem over here is I see a cosine x in it. I'm supposed to see signs all over the place. So I'll write this over here. Cosine of x. I'm going to use a cofunction identity. And that's sine pi over 2 minus x. They're identical. So the first thing I would do is rewrite this so it looks like what I want. I'll write this over here, pi over 2. And what do you get on top? Let's see, the root of sine x. You get dx over here. And then you would get, I'm going to put this one first, by the way. That would be sine of pi over 2 minus x. And then plus the root of sine x. And again, it looks just like this guy. What am I going to do now? Write it down. How do you do that? Well, let's write this down. So it's going to be pi over 2 minus 0 over 2, which turns out to be pi over 4. All right? That's written over here with the work as well. All right, let's go to the next one. Next one's more difficult. But again, I'm assuming it looks sort of like the other one, but there is a problem here. This x squared, I'm looking at it, it's a problem over here. So I'm going to say I wish it weren't there, but it is there. So what I got to do is I got to figure out what to do. And what I'm going to do, I'm going to use a u substitution to take care of it. I'm sorry about that. I'm going to use u substitution to take care of that. Let me write this over here. U, whoops, I didn't mean to do that. U is equal to x cubed, and du is going to be what? That's going to be 3x squared dx. Let me see if I can do that. And I'll write this one over here. So it's going to be log, I'm cubing it, by the way, 4. This would be log, I'm cubing that, 3. Well, I got 1/3 sine of u du. On the bottom, I'm going to get sine of u plus, I can get my eraser because I need more room. And that's going to be sine. And I want to point out log 12 is the same thing as log 4 plus log 3. And then it's going to be minus x cubed. I'm sorry, minus x cubed is u, right? I don't want to put that down. It looks like it. It really does. So I can write it down now. What's going to be 1/3. Whoops, that's not a third, is it? 1/3. That's going to be log 4. I'm using the formula. Minus log 3 all over 2, which is going to be 1/6 of the log of 4/3. All right? Again, work is down over here for you. Notice I made a mistake over here. I'll correct that. And are we getting the right answer? Yeah, we're getting the right answer. Again, I think it's kind of tough. I really do. Again, I want to encourage you that you reach out to me. My name is Ron Bannon. These are the course notes from my Math 122 class, which is Calc 2, which I don't really teach much anymore. And, oops, I need to do that again. But if you need to reach out to me, again, my name is Ron Bannon. My email address, Bannon, B as in boy, the @ symbol, NNON.US. And thank you for listening.